Okay, now what we need to do is let you try example number 2. We'll give you a few minutes to work on this, so please pause the video. So we'll do example 2, and then we'll talk about the p-value method for solving these hypothesis testing problems. So pause the video, do example 2, and then we'll come back and compare our notes. Okay, let's see how you did. So basically, we're checking to see if the home team has a better than 50% chance of winning. And we're going to take a sample of the 2018 Snow College softball team, where they won 13 of 20 home games and lost 10 of 20 away games. Probably not believe in the home court advantage for this, or home field advantage, because this was only one team for one season. The question now becomes, which parameter are we dealing with? So we've actually got a binomial here because either the home team wins or they don't. So we've got two outcomes. There's a fixed number of trials. In this sample, there were 40 trials. The home team won 13 games and then 10 games. So 23 out of the 40 games, which is a little more than 50%, but not much more. And the chance that one home team wins doesn't influence the chance that some other home team wins. So we definitely have a binomial where a success is that the home team wins. Okay. Since it's a binomial, we're dealing with the population proportion P. Therefore, our alternate hypothesis, the claim we're putting on trial, is that the home team wins more than 50% of the games. Our null hypothesis is going to be that the home team wins 50% of the games. You could also write it as the opposite of this, wins less than or 50% of the games, less than or equal to 0.50, but either way will be acceptable. And since our alternate hypothesis is dealing with greater than 50%, we expect our problem to be right-tailed. We remember that the type 1 error would be concluding that the home team wins more than 50% of games when in fact they do not. A type 2 error would be concluding that the home team does not win more than 50% of the games, when in fact they do. And we're going to be using the Z distribution because we've got a population proportion. It's a binomial. Okay. And we're going to do our requirement check. We had a binomial. We talked about that. We had a random sample. And on a hypothesis test, we do have a claim for what little p is. So we're going to do n times p and n times q. And since we had a sample of 40 games in here, n times p would be 20 and n times q would be 20, which are both greater than 5. So the normal approximation with the binomial would fit very nicely here. So we will use the Z distribution. So we'll draw our Z distribution, and we found that the critical value, so if we have 5% of the area to the right, that would be 95% to the left. And so 95% to the left, because that's what my Z table tells me, is between these two guys, and that's how we got the 1.645 for the critical value. And then we actually were given on page 3 that the test statistic is 1.82. And that landed in the critical region. So our conclusion would be to reject H naught. There is enough evidence to conclude that the home team does win more than 50% of the games. Now that doesn't prove it, because to prove we would need 100% certainty. And to have that, we would have to have all the data, all teams, all sports, and we probably don't want to take the time to do that. So let me pause this video here, and we will do one more on talking about how to get the conclusion using something we call the p-value, aka the probability value.